Hey, boys and girls. So today we are going to focus on area again for math. We're going to be looking at the area of rectangles and also rectilinear shapes, which are basically shapes that are made up of more than one rectangle. This is a very common skill, meaning this is a life skill. You're not, this is just for like the third grade math test. This is not going away anytime soon. So it's really important that you understand how this works, how to do this. Um, in the real world, if you're looking at a floor plan of a house, that's what they use to design a home before the building it. You might see something like this, where it's basically a bird's eye view where you have x-ray vision. You can look through the roof, or you imagine like there's no roof, and you can see where all the walls are, and then there's measurements, there's dimensions that are all written down on here. So like, let's say this looks like it might be like the top story of a double level house. So if you go up the stairs, these would be the stairs. You come up, there's a bathroom right at the top of the stairs, and there's a hallway. These are like the little doors. You can go into bedroom 2 here. You go down here and go to bedroom 1. And if this happens to be what your house at home looks like, it's purely coincidence. I just made this up. But somebody might ask a question, well, how big is bedroom 1? And when they ask how big it is, they usually are referring to the area. Sometimes it's referred to as square footage. I don't know why. I mean, it's measured in square feet, but square footage, I didn't even know was a term. But people say that a lot. It's really the area when you're measuring square footage. So what you would need to do is measure the length and the width of the bedroom, assuming it is a rectangle shape. So 8 by 11. The length, remember, area, the formula is length times width, and it's measured in square units, in this case, square feet. So we would do 8 times 11, length times width, equals 88 square feet. And I could put a SQ for square and FT for feet. Now, what if somebody said, well, how much space is in both bedrooms combined? Like basically they want you to find the sum of the areas of the 2 bedrooms. Well, you need the length and the width of bedroom 2, which we have here, 10 by 15. So you would have to multiply length times width again. That seems kind of intimidating at first, but it actually is pretty easy when you learn the trick times 10. It's basically a 15 with a 0. And then I'm going to write feet with a little floating 2. That also is a way of writing square feet. So bedroom 1 was 88 square feet. Bedroom 2, the area was 150 square feet. So let's add these 2 up. I'm going to use my standard algorithm, stacking, lining up my ones place, my tens place, my hundreds place. 0 plus 8 is 8. 5 plus 8 is 13. And I can't put my 1 down, so I'm going to kick it up over the 1. So 1 plus 1 is 2. The answer is 238 square feet. And that's the sum of both bedrooms combined. So that might be a question somebody asks. Now, realistically, bedrooms are shaped not just in rectangles, they're actually more rectilinear shaped rooms because of a closet. This space right here, maybe there's a closet doors right here over in the corner. So this is what a bedroom would typically look like. So as you can see, if we tried doing the 9 times 11, because we looked, that was 9, that wall, including inside the closet all the way over, is 9. And then the wall across the long wall would be 11. If you did 9 times 11, that's 99 square feet. The problem with that is what you're actually doing is finding the area of this rectangle, and you are including this space that's not even part of the room. So your calculation is overshooting what the actual area is. So we have a problem here. So how do we solve it? Well, if you notice, this is a rectilinear shape, meaning it's made up of a couple different rectangles. So we could actually divide it like this, and we have one rectangle here and one rectangle here. Or this is the way I like to do it. I cut the closet off. Now we have one rectangle, one big rectangle, and then one little rectangle for the closet. And then you would find the area of both of those rectangles and add them up, finding the sum, just like similar to what we did up here. So let's do it. 7 times 11 is 77 square feet. That's the area of the main part of the bedroom. And then the closet is 3 times 2 is 6. I don't have room for units, but you get the picture. 77 plus 6 is going to give us the area of the bedroom. So 6 plus 6 would be 12. So 6 plus 7 is one more. Double plus 1, that's 13. Kick the 1 up. 7 plus 1 is 8. So our answer is 83 square feet. Now, let's take a look at this same bedroom. We already know the answer. We already know what the area is. But I wanted to take a look at it in a different way because sometimes you're going to get these problems where you have missing values. If we wanted to cut it into 2 rectangles, we would need the length and the width of that closet, wouldn't we? Problem is we don't have it. We need to use the information that's given to solve for the dimensions of the closet before we can solve for the big picture. We already know we could solve for the main part of the bedroom, 7 times 11, that's 77. But how do we find out this length of the closet wall and this width of the closet wall? And the trick is use opposite sides. So for instance, this whole wall from here to here is 9 feet, but how long is it from here? Well, we know that this right here is 7 feet, and this is 9 feet. So if I drag this 9 all the way over here, this 9, basically, this is the length of this wall over here. And if I take a look at just this part, we know that that's 7. And the question is, how long is it from here to here? If we find that the distance from here to here, then we know that's also the distance from there to there. So if the whole thing is 9, and from here to here is just 7, what's the difference? This has to be 2, because 7 plus that 2 would equal 9, or 9 minus the 7 equals 2. So from here to here is 2, and since it's a rectangle, the opposite side, it's also 2. So let me find my eraser. I'm going to erase this. So now we know for sure that this length right here is 2. You can't just eyeball it. You're not supposed to just look at it because sometimes it's not to scale. Some of you guys could have just looked and said, well, if that's 9 and that's 7, that's got to be 2. You have to actually do the math. We took the long side minus one of the short sides, and we got the other short side. Okay, so now we solve for one part of that closet, the length. Now we have to do the width. And we're going to do the same concept. We have 11 feet. This whole side over here is 11 feet long. Okay, we don't know this side, but we do know that this from here to here is 8 feet. So this side that I dragged over here, that's 11, that's 8. Well, how do we get from 8 to 11? If this is 8, how many more to get to the 11? Because the whole thing is 11. Well, let's count on 8. So we go from here to here is 8, and then we go 9, 10, 11. So this has to be 3 jumps, or 3 feet. So I'll erase this, and I'm going to write in my 3. So now I know the dimensions of the closet, and I know the dimensions of the main part of the bedroom. Obviously, we already knew this from the previous problem, but the detective work is important if you don't have all the side lengths given. So we could solve this as a 6, and this is 77. 77 plus 6 is 83 square feet. Now, here's another example of a rectilinear shape, but sometimes it's not just where you have, like in this last one, we knew the long side and we knew an opposite short side, and we had to find the missing short side. Sometimes like 2 of the short sides, but you don't know the long side. Like if I divided this into 2 rectangles here to find the area, I have to solve to find this. What is the length of that chunk or that wall of the bedroom? in order to find the area. So it's the same concept. We're still looking at opposite sides. So if you look straight across, here's one of the opposite sides, but it stops right here. But then if you keep going straight across, here's another opposite side. Okay. So using the opposite sides, we'll be able to find the length of the long side. So here's 1 yard. And if this is 3 yards, they will combine. Well, 3 plus 1, it has to be 4 yards for this side. Notice we switched to yards too, by the way. I didn't. So you can measure length in all different kind of units. Those were feet. Now we're doing yards. It could be meters. It could be, I mean, depending on what you're measuring, it could even be miles or kilometers if it's you're measuring like city blocks and stuff. So, anyways, so now we can calculate the area of this chunk of the bedroom. 4 times 3 equals 12 square yards, and I could do the yards, YDS, and then a floating 2. And then we could also calculate, we already know this is 3 and this is 4, so we don't have to do any detective work here. Another 4 times 3 is 12 square yards. And if you know 12 doubled or 12 plus 12, it's 24 square yards. And it doesn't matter if you write square, you could write it out square yards like this for your units, or you could just write SQYDS, or you could do a YDS with a little floating 2. My favorite is the YDS with the floating 2 because it's faster and it's kind of cool. Finally, you might get a room that you could either divide it up into 3 rectangles and find the area. Actually, the easiest way to do this one is this is just 2 that are kind of staggered. So if you do 7 times 5 is 35 square yards. And then over here we know 4 and 5. So 5 times 4 is 20 square yards. And then you add 35 plus the 20. I didn't even need to write it out because I could have just done it in my head. But 55 square yards. That's the area of that entire bedroom. So once again, as always, you can go back, you can rewind, pause, fast forward to the part that you need help on. And this video will hopefully be useful for you today when you're doing today's activities. Thank you for listening and good luck.